Hello friends, welcome to ASTA Academy lecture series on advanced mathematics. We are into algebraic expressions and this is the lecture number 4 within algebraic expressions. Today we are going to look at what are the rational expressions, how do we use the flipping in the dividing fractions, and how do we use the splitting fractions. Okay, so it's going to be a short lecture. So let us first start with rational expressions. Okay, well, we know what are the rational numbers. Okay, so it's like 2 by 3 is a rational number. Okay, which has two parts. You have a numerator and you have a denominator. Okay, similar to the rational numbers, we have rational expressions. Okay, which is what? Nothing but the ratio of polynomials. Okay, which is nothing but the ratio of the polynomials. Example, you have x plus 2 is an expression, algebraic expression in the numerator, and then you can have x minus 1 or anything in the denominator. Okay, sometimes you will have questions on SAT where you will be given a trinomial, you may need to factorize it, and then you have a rational expression and certain factors will cancel out from the numerator and denominator. Okay, so the trick is that you may need factorizing. So what we learned in the last lecture, we may need to use it here, factorizing. Okay, we also need to use the identities. Okay, 3 identities we have looked at, and this is something very important. Okay, because I'm going to be using this in the next example. Okay, so another example is you have to simplify this expression, which is a rational expression. Okay, as soon as you look at it, you should realize that there is an identity of this type which is going to be useful here. So you convert the expression using the identity in the numerator, which will be x plus 3 into x minus 3. Okay, divided by x plus 3 is already there. Okay, now no matter what the value of x is, x plus 3 and x plus 3 will cancel out and your rational expression will get simplified to x minus 3. Okay, so you treat the rational expressions in the same way as you have done rational numbers. Okay, I would like to take up another example, okay, which is x squared plus 5x plus 6 divided by x plus 2. Okay, now we just looked at finding the factorization of trinomials. Okay, here a is equal to 1, so the first case will be applicable. Okay, so you can say that a into b is equal to 6, all right, and a plus b is equal to 5. So you have to find two factors, two integers a and b, such that their product is 6 and their sum is 5. All right, it's no rocket science, it's going to be 3 and 2. Okay, so you can directly write, because it is cased 1, so this will be x plus 3 into x plus 2, all right, divided by x plus 2. So you see how we are using our knowledge in this chapter from the previous topics, okay, of factorizing and identities. So we have x plus 2 cancelling out and the answer is going to be x plus 3. That's your answer. Okay. Now there could be another type of problems that will come on the SAT in which you may need to add or subtract the expressions. and we are talking rational expressions. Okay. Depending upon the kind of problem we have, we can solve it in one or two different ways. But first one of them is essentially you have to find the LCM using the denominators. There are two rational expressions given to you. You have to add those or subtract those. Okay, like you used to do. Let's say 2 divided by 3 plus 4 divided by 5. How will you do it? You will find the LCM of these two numbers. In a similar manner, when you have two rational numbers, you will need to find the LCM of the denominators of the two rational expressions. So let us look at this method, an example of LCM, or maybe let me just write the second case in which what we'll do, we will multiply or divide, okay, by an uncommon part of denominator. Okay, this will be clear when I take up an example. Okay, so first look at the example of an LCM. Okay, you have, let's say the example is 1 divided by x plus 2 plus 2 divided by x minus 2. So these are the two rational expressions and we need to add them up. Okay. Well, we can take the LCM, which is x plus 2 multiplied by x minus 2. All right. Then you have to solve for the numerator, the LCM divided by this guy here. All right. You will have x minus 2 coming from here. Then there is a plus in between the two expressions, so the plus will go as it is, and then x minus 2 gets cancelled. All right, so you will have 2 times of x plus 2. Okay, simple math. Then you need to simplify the numerator here. Okay, so this will be equal to your x minus 2 plus 2x plus 4. So you are distributing 2 to x plus 2 divided by x squared minus 4. That we have used the identity. So you simplify this, you will get 3x plus 2 divided by x squared minus 4. Okay, so this is the answer to adding these two expressions. Okay, so this is your answer. Okay, it cannot be simplified any further. Now the second case, I'll take up another example in which you want to multiply and divide by an uncommon part of the denominator. Don't take the LCM always. Here it was okay. Okay, but things can get complicated and there are other ways to get around. So let us see that we have a case like this. This is the first rational expression. The second one is 18 divided by x squared plus 3x. Okay. Now we have to do a little bit of thinking here. There is an x plus 3 here and there is x squared plus 3x here. So if you take the x common, all right, what will this guy be equal to? This will be x into x plus 3, right? And then there will be x plus 3 which will be common and x that will be not common. So let us simplify this. If you want, you can take this as the common, all right, x into x plus 3 and solve it the way we have done the first problem. However, like we said, multiply or divide by the uncommon part of the denominator. Okay, that's what I'm trying to say here. Okay, this guy here. Okay. Okay, so let's do that. So what we have is I'm going to multiply by x here and divide by x here. Okay, I can always do that to any expression, multiply and divide by the same number, right? So this will be equal to 6x divided by x into x plus 3 plus 18 divided by x into x plus 3. So essentially what we are doing, we are making denominator same. That's the idea here. Okay. So if you did that, because your denominator is same, this will be sum of your numerators 6x plus 18 divided by x into x plus 3. Okay. In the numerator, you will have 6 as the common, and other factor will be x plus 3, and then you have x into x plus 3. Okay, x plus 3 gets cancelled out, and this is equal to 6 over x. Okay, so 6 over x is your answer, which is quite compact to this problem. Okay, where you have to add two different rational expressions. Okay, now the next topic we are going to do is flipping dividing fractions. This is similar to flipping the dividing fractions of your numbers. Same rule we will apply to the fractions. Okay. Now before we move this, I'm going to ask you, what is the difference between 1 by 2 divided by 3 and 1 divided by 2 by 3? Okay, could be confusing, but there's a lot of difference. The difference is in the larger division line. Okay, what is the important part? The larger dividing line. That is where you do the flipping. Okay, so 1 by 2 whole divided by 3 is equal to what? You can write it as 1 by 2 divided by 3, right? And when you divide by a number, you multiply by the reciprocal, right? So 1 by 2 multiplied by 1 by 3, which is going to be 1 by 6. The other case, you have 1 entirely divided by 2 by 3 will be equal to what? 1 divided by 2 by 3, which is equal to 1 multiplied by the reciprocal, which is 3 by 2, and the answer is 3 by 2. So you see that this is the difference in these two quantities. Okay, the answer is different. Okay, you will use exactly the same logic when you are dealing with expressions. Okay, I'm going to take up an example of expression. So you have 6 divided by 24 divided by x. What is this equal to? Well, you can write it as 6 divided by 24 by x. This is going to be equal to 6 multiplied by x divided by 24. You just flip it. Okay. So 6 ones are 6, 6 fours are 24. So this is going to be x by 4. Okay. So this is how you deal with division of expressions when you have multiple expressions and dividing. Okay. So you use the larger line for division. The last topic in today's class I would like to look at is splitting the fraction. Splitting the fractions. Okay. Sometimes it is easy to simplify certain thing when we can split a fraction. For example, let's say you have a rational fraction given as 30 plus c divided by 6. There may be a question which will ask you its simplified form in ABCD, multiple choice questions. So it is easy to see that 30 can be divided by 6. So we can split the fraction. Okay, 30 divided by 6 plus c divided by 6. Okay, which will be equal to 6 plus c by 6. All right. Keep in mind that this kind of splitting is done based on numerator only. Okay. If in the numerator you have plus or minus, you can do the splitting like this. But you cannot split when you have the denominator. All right. For example, 3 divided by x plus y. Can you split it? Somebody might say this is equal to 3 by x plus 3 by y. Is that correct? No, sir. It's not. Okay. So you cannot do the splitting based on additions and subtractions in denominator. Okay. So I think I'd like to stop here. So today, essentially, we have looked at the rational fractions, dividing and splitting, these two type of things essentially. Okay. So I request you to try out some problems which are given at the end of this chapter and also in the question bank. Good luck. Thank you.